Good morning, good afternoon, or good evening, depending upon where you are in the world, and welcome to the latest installment in the BlackHat webinar series, SBOM, Log4j, and the Future of Transparency in the Software Supply Chain, brought to you by BlackHat, Traceable AI, and Informa. My name is Steve Paul. I'm with BlackHat. I'm your moderator today, and we have just a few announcements before we begin. This webinar is designed to be interactive between you and our presenters, and later in the program we'll ask for your feedback. We strongly encourage participation and are happy to take your questions and comments. You can participate in our Q&A session by asking questions at any time. Just type them into the Ask a Question text box on the bottom of our console. We'll answer as many questions as time permits after our presentations. Slides will advance automatically throughout the event, and PDF copies of our presentations can be found in the resource box on the bottom of our console. At this time, we recommend you disable your pop-up blockers. And if you're experiencing any technical problems, please visit our webinar help guide by clicking on the help question mark icon on the bottom right of our console. If slides are not advancing, please press the F5 key on your keyboard to refresh your console. And now on to our presentation, SBOM, Log4j, and the Future of Transparency in the Software Supply Chain. Discussing today's topic will be first our guest presenter, Dr. Allan Friedman, Senior Advisor and Strategist with Cybersecurity and Infrastructure Security Agency. And then we'll hear from our sponsor presenter, Anoop Kartha, Senior Solution Engineer with Traceable AI. First, we'll hear from Allan.
Thanks so much, Steve, and thank you everyone for taking the time to chat.
Hello and welcome to Logistics Management's annual.
We're very excited to talk to you about SBOM, and hopefully, you can decide whether this is worth the next 30 minutes of your time, or if you want to hang out, do something else, and catch Anoop's presentation in just a moment. We're going to give an overview of SBOM, where the status is today, and then what comes next, and ideally convince you that if this is interesting to you and your organization, how to get involved. And the quick takeaway here, as we think about Log4j, is that SBOM won't solve all of our problems, but it is going to be a foundational infrastructure piece that it is going to make the entire ecosystem more resilient as we continue to understand the risk that comes from not just open source, but a very complex and diverse supply chain that we can't fix quickly and easily. So I want to start off by talking about some cliches that I traditionally avoided using when we talk about cybers. Right, one of the things that we always say, in addition to the crosshairs made up of ones and zeros, right up there is no silver bullet. I've always hated that cliche, so I've never used it when talking about SBOM. But it turns out it's actually probably something that I should have used, because one of the challenges is we have to remind people that the SB in SBOM doesn't stand for silver bullet. This isn't going to solve all of our problems, but it is going to be such a foundational piece to understanding how we're going to address risk. So one analogy that I've heard that I like is, hey, if someone handed you a bunch of cans that had no label on them and no information on them, would you sort of accept them? Would you sort of trust them? Well, maybe someone has given you cans before and it's been okay, but it probably isn't the greatest approach for risk. And similarly, if you're someone who gives out products, you want to make sure that your customers and your users have some idea of what's in there. And indeed, we have this model of transparency that works fairly well in other sectors. So if you go to the store and you buy a Twinkie, it's going to come with a list of ingredients. Why don't we expect sort of that level of transparency for the software that's running our critical infrastructure? It turns out to be a pretty effective approach. Now, again, going back to the idea of how will it actually solve us, a list of ingredients doesn't magically keep you on your diet. It doesn't magically protect you from an allergen. You still have to consume the data and map the data, but it's very difficult to have the priority if you don't have this information. And so that's really the vision here, is to lay the foundation and the infrastructure for this. One of the basic foundations of all of security is knowing what you have. Right, this is step 0 in any guide. It's the #1 piece of advice in the NIST cybersecurity framework, right? Knowing what you have, you can't defend what you don't know about. Now, sometimes it's just enough to say, I am using this major product by this major vendor because as soon as I know that, I know everything there is to know about the risk of having that. But too often there are real black boxes here, especially as we move into a more diverse network. Many of you are now sort of thinking about, hey, it's not just about endpoints. It's about more complex devices. It's about cloud native components. It's about telecom or critical infrastructure side of things. And of course, we've all come across a very recent challenge of knowing what you have, which is, gosh, once we really need to know what we have, then it's going to be very clear to actually chime in and say, is this effective? Now, I'm going to assume that most of the folks who've tuned in today are familiar with the Log4j library and the vulnerability that ate most of our Decembers. If you're not, there are tons of great resources out there, including a number of blogs that are probably written by the BlackHat Review Committee. And so I'm going to invite that as an exercise to the room. What we do know about Log4j is that it was buried deep in the ecosystem in a whole bunch of pieces of software, and it was very expensive and time-consuming to figure out who was affected, how do we understand where it affects us, and how do we remediate it. Even the challenge of prioritizing it was quite difficult. So the knowing what you have model, again, fits into a broader ecosystem. So it starts with, again, the very basic idea of asset management. What do I have on my network? This is, a combination of scanning tools and commercial off-the-shelf tools. Some of you have rolled your own, and that's great too. You can think of SBOM as the next layer down. So once I know that I have this box, the next step is going to be to sort of understand what's inside the box, what's under the hood. Rather than having a black box problem, we can understand what's inside it. And it's not just about the defender approach. It also really applies to people who ship software. This is the whole ecosystem approach. Knowing is absolutely important. If for no other reason that your customers are going to ask you. And if you don't have that data at your fingertips, it's going to be a very expensive concept. But even more importantly, when you come across a vulnerability, having this data as something that is built into your information system in a machine-readable fashion is going to be very helpful. The head of product security for one of the largest manufacturers of industrial control systems has said, you know what? If we had transparency for all of our components today, it would save us hundreds, if not thousands of hours a year, because every time a new vulnerability comes along, they have to figure out what might be affected. So, Allan, you've been talking about SBOM for a little while. Haven't actually told us what an SBOM is. Okay, let's dive in. SBOM is a powerful tool for transparency, but what is it? At its core, an SBOM is a dependency graph. So let's take a look at a little toy example here. We have Acme application, or if you're in hardware, we can call this the Acme appliance. An Acme application has two dependencies. It is built on two software libraries, Bingo Buffer and Bob's Browser. Bob's Browser, in turn, depends on Carol's compression engine to function properly. Now, for each of these components that are in our supply chain, we don't need that much data. There could be a lot of data that we could want, and I'll talk a little more about that later. But we need to understand what's the supplier, who made it, what's the component name, what's the version, right? Is it an up-to-date one or out-of-date? What are some of the identifiers? How can I map it to other databases? And then what's the author of this data? Did the data come from my supplier? Did it come from something further upstream? Did it come from a security tool? So it's not all that complicated. The other thing I want to flag is we're explicitly acknowledging known unknowns. So in this case, we know that Acme application has exactly two dependencies. We know that Carol's compression engine has no dependencies. It's the root or leaf of our tree. In this case, we simply don't know if Bingo Buffer has any further dependencies or not. And how you respond to that uncertainty is going to be a choice about risk. Do you need more information? Are you going to go back to your supplier and say, no, that's not good enough? Are you going to throw your red team at it? Are you going to throw a source composition analysis tool at it? There are a number of things you can take. The important thing is that you know what you don't know. And of course, this is all going to be machine readable. And I'll talk about the data formats in a little bit. So if this is such a great idea, why aren't we already doing this today? Some of it is based on an outdated concern about licenses and open source restrictions. Until very recently, a whole bunch of fairly sophisticated software companies, I don't think could honestly say that they were following all the rules around open source use. Right? The different open source licenses have different requirements, and let's be honest, not everyone pays attention to them. Today, I think it's a much better understood risk. There are international standards of things like OpenChain to help you manage it. There are commercial off-the-shelf tools that help you understand it. Every startup I talk to knows that they're going to have to go through an open source audit. So I think we understand this risk today. It's also hard. A lot of the benefits I'm going to talk about require machine readability for automation, which means we need to do some of the advanced work to actually get it done. And it's not just hard, it's complex. It's what some people call a wicked problem, because it's not just engineering. We have to understand the operational details, the business issues, the incentive issues, and it involves managing a more complex market. So the benefits accrue across the entire software supply chain, right? It helps people who produce software, who choose software, or buying software, and people who are operating software. And the value, right, it doesn't just accrue to one part of it. So if you're in the business of making software, and a lot of us are, you want to have a secure development process, it's very difficult to claim that you have one if you're not tracking all of the different components that are in your software. And so why not communicate that downstream that you have that data, and ideally share it with them. Similarly, if you're about to buy software or select an open source project, you're going to want to know a little more about what that software came from. Is it using up-to-date, let's return to our ingredients analogy, is it using the freshest ingredients from the best producers, or is it using things that came from kind of shady corners of the internet, or even worse, we simply don't know? Having that visibility is going to help you, and also understand risk management. And then last, once we're running software, especially on our own networks, we need to think about vulnerability management. Again, let's go back to Log4j. What on my network actually might be affected? Well, if I have an SBOM for things, I can tell, hey, you know what? This thing doesn't have Log4j in it. I don't need to worry about it. These things I now need to put on my patch list. I maybe need to tune my intrusion detection system. There are other things that I can do. So, how are we approaching this? Again, we want to think about it from a market perspective. We need to understand how SBOMs are created, and we need to help them be consumed. And we need to do both of those in an automated fashion. Right? This isn't something that we're going to want to do manually. If we're doing it in Excel, you're doing it wrong. And I'm sure some of you have had to sweat blood, tears, and weekends getting your organizations away from sort of an Excel model of compliance. So first step is to make sure that it's automation friendly. When we first launched this SBOM effort 3 or 4 years ago, we didn't want to create a brand new standard. And the good news was at least one community came forward and said, we've got a data format that can help with this. Slightly less good news is that more than one came forward. But that's okay. Right now, today, there are really two widely used SBOM data formats. SPDX, which is a Linux Foundation project, and CycloneDX, which is an OWASP project. They're both amazing projects with amazing people involved. They're both open source. They both have opportunities for people to get engaged. And most importantly, for our purposes and for the purpose of this conversation, there's interest in both communities in having harmonization and cross-compatibility. We know that neither of these is going to be used completely and universally. And so the vision is to make sure that if your organization gets an SBOM in one and an SBOM in another, we can translate, we can harmonize, we can use them together. It's not going to be a perfect overlap, but there is going to be interoperability. There are translating tools today, and there'll be more down the road. We also want to understand some of the nuances of where we're drawing this SBOM data, because not all SBOMs are taken from the same place. There's a general emerging idea that the ideal place to understand transparency is at the time of software build. Right? This is when you are going from source to binary and you're pulling in a lot of things, right? This is when we have statically linked and dynamically linked pieces of software. You're going to incorporate all sorts of things like config files, so you have the maximum visibility. And you're actually sort of recording what has happened. Right? It's not just this should be what's in my product. It's this is what is in the product. However, there are going to be plenty of times where that's not sufficient. One is if I'm looking at a source repo, well, then obviously I'm not building it. So I want to have some visibility in a source repo to say, hey, what does this repo depend on? What does the source code depend on? So there's always going to be value for having transparency of source. And we know that not everyone is going to have access to software suppliers that are building SBOMs today. And so there is a large and thriving market for binary analysis tools, source composition analysis tools, and including some open source projects out there for folks who want to look more at the binary side of things. This is also going to be particularly useful for things like industrial control systems and the embedded space, where we're going to see more of this, especially in the medium term. So it's important to acknowledge where we are in the supply chain. The other thing that we often get questions about is how deep should this dependency track go? And some people say, can I just give you the top line dependencies? That's really what I'd like to give you. It seems really hard to go deep into this. A couple responses. One, something is better than nothing. And the minimum model of an SBOM is to provide enough information to enable further recursion. So someone who gets the SBOM on the left can at least go and say, all right, well, once I know that this is the top level dependency, I can do the work to find out what those further dependencies are, especially if some of those are open source. However, if our vulnerability is pretty deep in our dependency graph, like say, I don't know, Log4j, then we're going to want to have as much data as possible, because not everyone is going to have the ability to drive as deep into the supply chain as possible. So if nothing else, Log4j has really taught us that as complete as possible is something that everyone should feel comfortable asking for, because we know it's going to be quite valuable. So hopefully you sort of have a sense of how we're thinking about this today. But some of you may be saying, hey, can we already do this today? And I'd argue that yes, we can. And in fact, there have been some communities that have been building this and building on this technology already. So for example, the healthcare sector, which relatively few of us think about as on the vanguard of IT security, has been making a lot of progress. Over the last 4 years, medical device manufacturers have partnered with healthcare delivery organizations to create SBOMs and start working on integrating SBOMs into hospital defense systems. There's more work happening in the energy sector, where CISA is partnering with the Department of Energy and Idaho National Labs to bring together suppliers and consumers, and even in the automotive sector. So there really is a lot of work happening, not just in the traditional software spaces and the advanced software spaces, but in areas where human safety and human lives really are at stake. So what's the current state of SBOM in 2022? I want to be honest and frank with you. I'd love to say this is magic, got it all solved, and you can. And the short version is there's no reason that we cannot start today, but we cannot assume full automation and integration. We're working on that, and I'll talk a little more about that. Tooling is still emerging. We're going to see markets coming up. Those of you who are interested in starting your own companies, I think there's huge room for growth, and I'll talk a little more about why. And we need to understand interoperability. And I'm also going to talk a little more about vulnerabilities. So let's talk about what are some of the gaps that we have today. So one is identity. We don't have a global namespace for software. You use com.sun.java or com.oracle.java. We're working on this. And in fact, the challenge isn't that we don't have any identifiers, it's that we have many identifiers. And our solution is to include a list of identifiers. You can use package URLs and CPEs as a way of using software identifiers. I want to acknowledge that not all vulnerabilities actually put you or your users at risk. Right? There are plenty of vulnerabilities out there that simply the way you're using the code isn't going to put anyone at risk. Right? Your compiler strips the affected code out, or you have inline controls. And so we're working on something in parallel called the Vulnerability Exploitability Exchange. And forgive me, this is probably the worst named project ever. Those of you who were able to attend BlackHat last summer virtually or in person may have seen a presentation that I gave explicitly on this about how we're implementing it. But the vision here is allowing an organization to communicate that my product is not affected by a particular vulnerability. So for Log4j, imagine how useful that would be if you had a machine-readable way of just something telling your network, hey, you know what? None of these particular software pieces or components or devices are affected by Log4j. I can ignore them. I can turn off all of those dashboards. Also want to acknowledge that most of the discussion around SBOM has really focused on on-prem software. We need to understand what the use cases are for SaaS and cloud native. There are some further complexities. One of them is API transparency. There are a number of different solutions out there. We're going to talk, Anoop's going to talk a little about one of them. Obviously, I can't endorse his company, but this is something that we want to get into, is to talk about all of the different pieces about how SBOM can be used by downstream customers and by vendors to understand what the risks are for not on-prem software. We need to have a better vision of tooling and interoperability. There are countless tools out there today. There are, I think, CycloneDX, one of the data formats, announced that they now have 100 different CycloneDX tools out there. That's a decent amount. More coming online every day. Every few days, I learn about a new startup that's doing something with SBOM, which is wonderful. What we want to do is make sure that there's interoperability so that the market really is functioning and constructive, and customers know what they're getting when they sort of start to put time and money into something like this. We need to understand how this data is going to move. Some organizations are going to make progress. So, for example, the CISA of a company called Jupiter1 said, you know what? I want to have my SBOM public. So when he became CISO, he said, we're going to create the website, jupiter1.com/SBOM. That's their live build. That's wonderful. We know that not everyone's comfortable with that level of transparency, nor should they be. And so we need to have some scalable ways of helping suppliers who have many customers get the data to the right people in a secure way. And similarly, customers of many suppliers managing it without having to do sort of an individual web portal for each approach. We're going to be focusing on on-ramps and adoption. How do we make it easier and cheaper for companies to understand how to SBOM? Some of that's going to be tools, some of it's going to be just helping people explain. And then lastly, we want to move beyond the simple idea of just saying know what you have and make sure that we actually can think through advanced threat models, right? So it's one thing to say, I need an SBOM because, and it needs to be some validation because maybe, but what if there's an attacker that's actively trying to interfere with the SBOM itself? Because if they can compromise that, then they can attack without me worrying about it if the SBOM itself is the fault. So we want to think about artifacts and attestations that are secure from the actual build process. And there's some great work happening, in particular, been growing up around the SALSA framework, slsa.dev. That's part of the Cloud Native, the Open Source Security Foundation. So there's some really fun. So, all right, this is all well and good for the general idea of doing this voluntarily, but the head of product security for one very large software company said, we like this idea. We want people to give us SBOMs. We'll provide SBOMs when someone makes us. And right, I understand that thing, that perspective. And of course, that is coming. In May of this year, the White House issued what's called an executive order improving the nation's cybersecurity. And one of the things from the preamble of that document is that the trust we place in our digital infrastructure should be proportionate to how trustworthy and how transparent that infrastructure is. So this executive order defines SBOMs and sort of explains the value proposition. It also defines the minimum elements of SBOMs and creates a model for the U.S. government to require that everything the U.S. government buys should ultimately have a software bill of materials. And I'll give you a hint. The U.S. government buys a lot of stuff. So what does that document look like? One, it's clear it's the starting point. It's the floor, not the ceiling. The document walks through a set of minimum elements, including, these are the data fields you need for each dependency. Here's the support for automation, and here's some insight into the processes and practices to deliver SBOMs. It also says, hey, minimum elements are fine, but if you want to go further than that, if you want to have more security than just what the minimum model is, there are different things that you can have. And we can dive into some of these questions in the Q&A. One broader challenge as we try to think about SBOMs for the entire software ecosystem is the idea that we need to balance uniformity or harmonization of implementation, because we all use the same software, especially in the open source world. And we need a certain amount of flexibility because we need to have, we know that different corners of the software ecosystem do indeed have different needs. So, wrapping up here, SBOM is part of a complete breakfast. And we all have different visions of our favorite breakfast. This is one of mine. It's from a guest house in the Caucasus in Georgia, a couple hundred kilometers from Tbilisi. One of the best breakfasts I've ever had. But your breakfast is going to be different. SBOM is still going to be part of that. And the future of SBOM is going to require a number of things. It's going to require industry leadership. It's going to require some government driving. We're going to see it integrated into specific standards and industry guidance. We're starting to see that already. So, for example, for our friends in Europe, good evening. Their SBOM has been featured in 2 different CISA standards that have come out of Brussels. And we're going to be expanding the use cases and the capabilities. So, to sum up, SBOM is a journey. It's not going to solve all of our problems, but it'll be very hard to solve any of the problems we know we face around software supply chain without this. We're going to need your help. And so here's the plug. If this is interesting to you and you'd like to get involved, there is a global movement to sort of build out expertise and participation. Reach out to SBOM at CISA.dhs.gov if you'd like to get involved. We have different work streams tackling some of the things that I've mentioned. If you're someone who likes to engage in conversations on Twitter, hashtag SBOM, or just reach out, find me on Twitter, and we'll have a fun chat. So with that, I'm looking forward to hearing about the API side of this, and then hopefully we'll be able to dive into some more details during the Q&A. Whoops.
Fantastic.
Steve, I can't hear you. I don't know if other people can.
Yeah.
Sorry about that.
All right. So let me start off by saying that, Dr. Friedman, it truly is an honor to be speaking right next to you on this webinar. And thank you so much, everyone, for taking the time to talk to us today. So I will probably go down the same theme, a real-world use case as we know it, which is Log4j, Log4Shell, call it what you want, right? By asking some very, very basic questions and trying to explore the answers around that. Starting off with, how do we go about identifying your vulnerabilities? How do we go about identifying your vulnerable applications? Obviously, we end up relying on things like your static scanners, scanners that go in and look for dependency trees, libraries, before maybe the app actually gets deployed, or before the code even gets compiled, right? There's a whole bunch of things that they end up missing out on. Some examples are given right here: dynamically loaded methods, classes, third-party libraries, JVM being a common runtime environment. You could very well have other tools, app servers as an example, running in the same environment, which might very well be vulnerable as well. And just like Dr. Friedman pointed out, tons of false positives as well. For instance, just because I've included a vulnerable library in my application doesn't mean that I'm actually using it. I might not even be calling that vulnerable method. Of course, it's not the best practice, but it's very much possible, right? And if you're fortunate enough to actually find a vulnerable application and that's actually exploitable, is it as simple as just going ahead and patching the software? Probably not, right? You have to do some kind of validation. You have to go back to your QA team, have them sort of run tests end to end, look for any backward compatibility issues, look for any performance degradation as a result of the patch. And how many patches have we already gone through with Log4j specifically? I don't know, 3, 4 maybe? So think about all the time that you're spending waiting for these patches to get certified. You still need some kind of protection while you are in that queue of certifying these patches. And that's where you go in and rely on your proxy vendors, right? That's where you ask those proxy vendors to be deployed at the edge. You start scanning for these exploit attempts using signatures, using patterns, right? And that's something I'm going to repeat again, using signatures and patterns. I'm going to spend a minute, just a minute to talk about that. So I've been in the security industry for quite a bit of time, and I've been watching the borders over the last few days, weeks, months since Log4j actually got announced, right? And at the beginning, you would see these attackers coming in with fairly straightforward attempts, right? They would just go in, pick one of the parameters. Let's just say it's the user agent parameter in an HTTP call, and they would try to inject a Jindy lookup method. I'm like, okay, that's cool. But then over the next few days, weeks, I would see them sort of expanding the attack surface, going after every parameter on the face of this earth and maybe even their mother too, right? And what do you do in response to these exploit attempts? You have to go back to your proxy vendors, have them update their signatures, have them update their patterns. It's, at the end of the day, a catch-up game that you're playing. Drives me nuts, but that's the reality of the situation. But instead of playing this catch-up game of updating signatures and patterns, what if you had a tool that would give you a live software composition analysis of your applications at runtime, taking into account all your dynamically loaded methods, classes, third-party libraries in the JVM at runtime? What if that tool would also give you a sort of map of your vulnerable applications that are actually exploitable, and then prevent those vulnerabilities from ever getting exploited with some level of guarantee, ideally 100% guarantee, without relying on signatures, without relying on patterns. And here's the kicker, without making code changes as well. Would that be useful to you? I would argue absolutely, right? So we have a number of customers, fairly large deployments that were actually impacted by Log4j. They had about, I would say, hundreds of Java applications that were eventually impacted by Log4j. And obviously their teams were spread really, really thin. And how did they go about handling this particular situation? Well, they used our platform to first and foremost identify their vulnerable applications, even those applications that were using vulnerable dynamically loaded methods, dynamically loaded classes, third-party libraries that were part of the JVM at runtime. From there, using our platform to get a live application dependency map, again, going back to Dr. Friedman, right? Understanding how those applications are actually being deployed in the wild. Who's accessing those applications? What are they actually reaching out to? What is this vulnerable application actually exposed to the outside world? Who are the users that are accessing these applications as well? What kind of data? Is this data sensitive? So now you have these metrics that can drive your decisions around which application, which vulnerable application at least, needs to be patched, needs to be tested, needs to be upgraded. Now, here's another question that you should be asking yourself as well. And this is a very, very simple question, but the answer can be very, very complicated, right? Can I actually upgrade all of my vulnerable applications? The answer might very well come back saying, maybe not. I've been in conversations with a number of our customers, and these are companies that have grown organically. They run software, in some cases, that have aged out, EOL'd. In some cases, they are even running software where the vendors who have supplied the software have gone out of business. How are you going to be able to upgrade these vulnerable apps? You probably don't even have an option of doing that. Do you really need to upgrade these applications? I'm actually going to argue that you probably can get by without doing that. Why? Because again, since our solution runs in the context of these Java applications, we have complete visibility. When I say our solutions, I'm specifically referring to Traceable. Since they are running in the context of these vulnerable applications, it has complete visibility into the dynamically loaded classes, the methods, the third-party libraries that are in the JVM at runtime. And in the case of Log4j, specifically, as soon as the library, the Log4j library, makes a call into the vulnerable method, in this case, the Jindy lookup method, our instrumentation can go in and intercept that call and prevent that vulnerable method from ever getting executed. This is pretty powerful. So I'm just going to say that again. Again, using our instrumentation, you can intercept a call to your vulnerable method and protect it, prevent it from ever getting executed. In the case of Log4j, of course, we end up creating a security exception. Does that mean that we are bringing down the vulnerable application? Absolutely not. This is a revenue-generating application in many situations, and you don't want to affect the availability of the application. In this case, what really is happening is that the Log4j library absorbs the security exception, gets handled as a no-op. So at the end of the day, you are getting the same result as you would with patching the application. The difference, though, is that you don't need to go through any additional certifications. Zero downtime. Effectively, the application continues to run with our software instrumentation. And with a 100% guarantee that no one, absolutely no one, will be able to exploit that vulnerable method as well, right? So with that being said, there's a number of different ways in which you can sort of absorb our solution. The most impactful one, obviously, being the one on the right-hand side over here with the in-app language agents, where we have full context into what's going on. We can intercept calls that might be going out to those vulnerable methods. But then, depending on your appetite to consume the solution, you could also deploy us at the edge in concert with your API gateways, with your load balancers, or right next to the application in the world of Kubernetes. You could very well have us run as a daemon set or a sidecar or in integration with your Istio mesh as well. So a variety of different ways in which you can consume our solution. At the end of the day, we want to work alongside the community, right? We want to make our solution available to you, especially in the context of Log4j. We want to make sure that everyone is protected. And that's the reason why we come out and open source the solution. You can download it directly from our site. We also have a free tier, which basically means that you don't need to give us a credit card. There's no time limits to the free tier. The open source version is, again, it's open source, it's free. There's a few interesting collateral that our marketing team has come out with as well. At the end of the day, I would welcome an opportunity for having a one-on-one conversation with any and all of you, just to understand your application security needs, requirements, and how we can help you in solving those challenges as well. And in case we cannot, that's fine. I've been in the industry for more than 20 years now. I think I can at least help you, guide you in solving these challenges. So just to kind of quickly summarize, this is Traceable. And super thankful to be here again, Dr. Friedman, an honor working with you as well. Thank you.
Okay, well, excellent presentation, gentlemen. Thanks very much. We're now going to go to our audience Q&A, and as a reminder, to participate in the Q&A, just type your question into the Ask a Question text area, and then press the Submit button. So due to time constraints and the size of our audience, we may not be able to answer all those questions, but we'll get to as many as we can. I want to also let you know that copies of the PowerPoint presentations are available in the resource box, and also alert you to that this time we have a feedback survey on our console, and we'd greatly appreciate it if you could check it out and give us your feedback. Let us know how we did and how we can prepare for future events. So at this point, I want to take a look at a number of great questions that have already come in here. I'll start with one for Allan. Early on, Sama asks, how can I get the SBOM of my COTS and other installed applications? Any tools?
So the easiest thing to do is to start to say, hey, ask your supplier. We think that there are going to be more and more people that are going to be asking suppliers for SBOM data. And so that's the most direct way, having someone else do this. The second challenge as we move into the ecosystem is to say, hey, if there are things on your network that you genuinely want to know and need to know what's inside them, there are sets of tools that can help you with that. In the source composition analysis framework, in the binary analysis framework, that market has really grown over the last couple years. I obviously can't recommend any particular product, but what I can say is that some vendors have specialized in particular verticals. There are some in the energy space, there are some and there are also ones that have specialized in particular types of technology, right? So Java applications versus Go applications versus, their Kubernetes and containerized tools. So I think that's going to help you figure out how to find the right.
Okay, very good. Thank you. Question from Jens. Do you know if there's any work being done for getting SPDX or Cyclone on, for instance, SNMPs or a dedicated IANA port?
So if I understand the question correctly, it's say, hey, can we find a systematized way of sharing SBOMs at the network level? I haven't come across that, but if we pop up a layer in the network architecture, there is one approach that the folks at the IETF has been talking about, using something called MUD, Manufacturer Usage Descriptor. And this is a model for providing transparency for devices on a network, in particular. The behind MUD is that a device that's sitting on your network, and it could work for any arbitrary piece of software, has a secure 509 certificate that points to a website that has arbitrary data that can help the network manage this. So, for example, it could have a snort profile so that your network can automatically allow list or deny list an IoT device. So that was the original model. There's been some great work that's come out of the IETF. There's an internet draft that says, well, I'll have my device securely point to the SBOM data as well. So that's one way that we can imagine doing this, where if you have the network access to a device, you can have network access to the SBOM. Another approach that we can see, again, following the sort of international standards route, is just to use well-defined URLs, right? And there's a whole bunch of security metadata that we now see at well-defined URLs, and I think this is we can explore is to say, why not just have example.com/SBOM make it available, so we can have it at the application layer rather than at the layer.
Okay, thanks very much. Anoop, a couple of questions here for you. So how much effort does it take to go through the process of understanding what your vulnerabilities are and then blocking them? It sounds like that could be really quite an effort to implement that kind of security.
So let's talk about the instrumentation itself, right? When we are talking about the in-app instrumentation, Given the history of the company, if you're familiar with the application performance monitoring phase, that's a fairly mature market that you'll see. And if you look at how they go about instrumenting these in-app agents, very identical sort of methodology is what we follow as well. In fact, the history of the company, our CEO, Jyoti, was actually the founder of App Dynamics as well. So literally zero code changes to your existing applications. We can attach, the software module can attach itself to the JVM at runtime. So it's bytecode instrumentation that's really being done. In the case of Kubernetes environment, just as an example, all you need to do is just assign some labels at a namespace level, and we'll be able to instrument all these applications at runtime again without making any code changes. Matter of minutes. That's pretty much it. And once that's been done, we have complete visibility into everything that's running in the JVM, and therefore give you visibility into all the packages and the vulnerabilities that might potentially be you might be exposed to. In the context of Log4j, we can immediately identify those vulnerabilities and again prevent them from ever getting executed.
Okay, thanks very much. Derek has a question. So how can open source projects facilitate and share their SBOMs? Either.
This is a phenomenal question. And some of you who follow what's going on the policy side as well as on the technology side are sort of aware that a whole bunch of policymakers suddenly discovered that open source is both important and has the occasional amount of risk, right? We can't just easily map it into some corporate risk framework. In fact, 2 weeks ago, the White House hosted a summit to think about open source security. One of the priorities that came out of that discussion was the need to have more visibility and transparency into the open source supply chain, and that means SBOMs. We're starting to see more open source projects have SBOMs, and in fact, over the holidays or right before the holidays, some folks published the first SBOM of Kubernetes. You say, hey, my software is too big for an SBOM. Probably not as big as Kubernetes. So we're starting to see more and more folks engage in this. They're all the tools that are out there. GitHub has provided some tools to start to integrate SBOMs directly into the source repo, and we're going to be having more. This is something that our friends at the Open Source Security Foundation have been really leading, and we're looking forward to partnering.
Okay, super. Thanks very much. We've got a question from Raja. Beyond Java, what other languages do you support? Anoop?
Yeah, that's a great question. So there's a variety of different languages that we support just out of the box. Again, we are based on open standards, which basically means that these software instrumentations work alongside existing agents that you might already have as well. So think Go, Python. Most of these popular languages, we absolutely support right out of the box as well. And then you also have the option of deploying us right next to the applications, in front of the applications as well, which pretty much covers all of the ecosystem that we would be running.
Okay, thanks very much. Just another reminder for our audience to please fill out our feedback survey if you could. We greatly appreciate and to know what you think of today's event. Also a reminder that we'll send an email out to you tomorrow, letting you know when you can watch this on demand or forward it to a friend. Allan, question here from Joe. You talked about SCA source code and binary analysis methods. Do you think one method is more accurate than the other?
This is a fun challenge because we get into it gets philosophical very quickly. What is truth, man? It depends on what we're trying to capture. And in the presentation, I try to sort of lay out that some of us care about the source, right? If you're just trying to say, hey, should I use this project? Well, then you may just want to know, where did the source come from? What's some information about the project? Is this project, does it have a large development team? Have they ever had a CVE, right? If you're going to use a large piece of open source software in your product, and they've never had a CVE against it, well, then they may not know how to accept vulnerability data. So that's where the source will be helpful. Build time is really important. Anoop talked about this a little bit, but essentially Anoop captures the ground truth of what is actually deployed. But again, binary analysis and SCA tools, there's some differences between them, do offer some distinction as well. One, they're also looking at the software in front of you. And two, again, it gets back to the idea that maybe the software wasn't built or it's legacy, and so there's value there. So I wish I could give you sort of this is the optimal way. I think for mature organizations that are building new software that have a decent DevSecOps process, that have a modern CI tool chain, there are some great tools that can slot into this today and that can integrate it into your build pipeline. There are lots of vendors out there in the CI/CD world who are providing SBOMs as a value add, and so that's, I think, a good place to start if you would consider yourself on the mature side. But it's never too late to start, and there are lots of great tools out there to help you get started.
Okay, thanks, great. Anoop, a question here from Sarma. How is the instrumentation updated for new 0 days?
Yeah, absolutely. That's a great question. First of all, new 0 days, that in itself is a big problem, in detecting when a new 0 day happens, right? By definition, you don't know much about the exploit itself, the vulnerability itself. So you have to rely on some kind of behavioral analytics to understand new vulnerabilities, 0 day vulnerabilities, and or exploit attempts against them. And that's where Traceable shines, because we are not just relying on well-known signatures or well-known patterns to identify these types of attempts. That being said, so once we see anomalies, once we baseline what is normal behavior, we'll start looking for anomalies. We'll map them to something that will actually translate to good or bad behavior. And that's something that I can go into a lot of detail on a one-on-one conversation. But once that 0 day has been identified, by the way, we will never ever claim that we'll be able to identify 100% of all the 0 days. If we say so, just turn off the webinar and we can just walk off, right? But once we make a best effort on understanding these 0 days, then the software can protect those identified vulnerabilities just naturally by virtue of blocking it at a network level. And then you can obviously update the software, the instrumentation itself, with specific instrumentation updates to block those access at a access method level as well. So that's something that can be updated directly from our backend SaaS cloud. At the same time, like I said, you have the network layer protection that comes naturally as a result of the identification of the 0 day.
Fantastic. Thank you very much. Allan, Justin says that he believes the DoD had has a requirement for SBOMs in their contracts, but are you aware of any other departments or agencies that are looking at this as a replacement in the near term?
So can't speak to any particular regulation right now. It's one of those fun rules. But what I can say is that we are going to see this more, right? It is explicitly written in the Executive Order 14028, which is ultimately going to say that things that the U.S. government purchases, starting with what's defined as critical software, are going to require SBOMs. And we're going to see more and more of this built into government contracts. I think we're also going to see this in regulation. Frankly, government gonna government. And what we're trying to do is make sure that this is something that industry and the broader community are ahead of. So, for example, I talked about the medical device community, the FDA, which regulates medical, has publicly signaled that new medical devices are required to have an SBOM up before they're approved as one of their security requirements. So I think we're going to see this fit into more regulation, and also I think we're going to see it in more standards and guidance that is industry specific or technology specific that often has the power of this. So I mentioned ENISA, our friends in Brussels that are thinking about security standards. I know that there's been at least one or two IEEE standards that affect electrical power software, and indeed the trade association, the Edison Electric Institute, which offers guidance for large utilities, has said, hey, people should start asking for SBOM. So I think we're going to see more, this is going to come up more and more. Don't be surprised if your customers start asking for SBOMs.
Okay, thanks very much. So we might wrap it up with this question from Stan. It's a two-parter, actually. Stan and a number of other people are quite interested in getting an SBOM T-shirt. So maybe you could let us know how that can happen. And then the other one's a little bit more lengthy, but we'll try for, he's saying that true zero-day vulnerabilities are being sold and bought on the deep web on a regular basis. And vulnerabilities such as Log4j is among them. So do you see any values for companies to have a presence in such a market in order to stay ahead of such major security exploits before they make their way to the rest of the general public, although not necessarily to purchase? So take it away.
So I'll say it's going to depend on your risk model, how much of a target you are. There are lots of sources of vulnerability data out there, not just the National Vulnerability Database, but other ways that you can find out about it. What I can tell you is that SBOM won't stop these vulnerabilities. What it does do is it gives you that resilience. It gives you that agile posture so that when you do find out about the risk, whether it's from your secret squirrel supply or whether it's from the fact that it's plastered all over CNN, you and your organization will be able to move faster. And we need that agility. That's the only way defenders can keep up with the bad guys. So if you are so committed to this that you not only want to join, but you want a T-shirt, I can't get you a T-shirt, but what I can tease, CISA is going to be sharing a new SBOM sticker with full 80s Trapper Keeper style. So follow us on Twitter, get involved in the conversation. We'd love to have you join the SBOM team.
Fantastic. Got to get one. Absolutely. So unfortunately, that is going to be all the time we have for this session. Great questions, great presentations. Thank you very much, gentlemen. And we want to thank our audience for attending today's BlackHat webinar, SBOM, Log4j, and the future of transparency in the software supply chain. Brought to you by BlackHat, Traceable AI, and Informa. Shortly after this live event, we'll send you an email reminder so you can access this presentation on demand. And on behalf of our guests, Dr. Allan Friedman and Anoop Kartha of Traceable AI, I want to thank you for your time. Have a great day.